Hi everyone, to continue our study of binary trees, we're going to look at how to process a binary tree recursively. So we're going to continue with a similar setup to our previous study. We're going to be working with a class to define node objects. Every object will have some data, a pointer to the node going down the left side of the tree, and a pointer to the next node going down the right side of the tree. Here's a sample tree, and we're going to be setting this up using a static array of nodes. In our static array, this node will be at index 0, this node will be at index 1, this node will be at index 2, 3, 4, 5, 6, and 7. So you can see the node at index 0, the left pointer references the node at index 1, and the right pointer references the node at index 2, etc., etc. So let's have a look at this setup in our IDE. I have created a node array. We're declaring it here, and it's an array of up to 8 nodes. And if we take a quick look at the node class, I've kept it very simple. The properties of the class are not private. I will be accessing them directly from other classes. And when we instantiate an instance of the node class, we're just going to set up the data left and right pointers. And as you can see, that's what we've done here. And this design corresponds directly to this design. Okay, it's exactly the same. Okay, so what we want to do is recursively sum every data item in the tree. Okay. So what we want to do is create a variable to store the result, and we're going to call a recursive function. I'm going to call it sum all items. And what we're going to do is send this recursive function. We're going to send it the tree every time we call it. And we're going to send it the node index that we are currently working on. So the first node, the root node, has an index of 0. So that's going to be our starting point. Okay? Now let's get out of, that's the end of main function. Let's now define our static function, which will return an integer, and it's called sum all items, and it processes a node array. I'm just going to call it T, and an integer, which is, I'll just call it pointer. Okay. Now I'm getting a big red line there because I should be returning something, and I'm not returning anything yet. Now then, as you know, our first pointer is 0, and the next pointer, if we go left, will be 1. So we jump to 1, and if we go left, the next pointer is 3. So we go to 3, and if we go left, it means we've reached the end of the left side of the tree that we're processing. Okay? So if our pointer becomes -1, we're not going to sum anything. We're not adding anything to the sum. So we're just going to return 0. If the pointer isn't -1, it means we want to grab the data and then go to the next node. We'll go left. Okay? So we'll return the current node's data plus a recursive call to sum all items. We'll send it the tree again, but we're going to update the pointer. Let's go left. Okay, so tree pointer dot left. I called my node array T in this function, so let's just change that to T. Now let's have a look at how this works. We start by getting the tree and an initial value of 0. If pointer is -1, well, it's not. We're going to recursively call t0.data, which is 13, plus the next call to the same tree, which will be t0.left. So this is now 1. That's 1. So the next time we call sum all items in the recursive call, we get the tree. This is now 1. 1 doesn't equal 1, so we don't do that. We return t1.data, which is 7, plus a recursive call to the tree's t1.left, which is 3. So the next time we call this function, we give it the tree, and the new pointer value is 3. 3 doesn't equal 1, so we return t3.data, so t3.data, which is 5, plus a call to t3's left pointer. t3's left pointer is -1. So we come around, we send it the tree, pointer is now -1, and that's true. We return 0. That means we're not doing the recursive call anymore. That's the end of our recursion. Okay, that's the recursive call finished, and things will start to unwind. And hopefully you understand that process from your previous study of recursion. So let's run this program and see if it works. It might be working. We don't have any output. Let's do a system.out.println sum, and let's see what we get. Now remember, we've only gone left, so we should get 13 plus 7 plus 5. We should get 25 as the answer. So let's run it again. And there you go. We get the answer 25. Now, when it's finished doing the left bits, we want it to do the right bits. So let's continue our return statement. We're going to do the same thing again. Give it the tree, but don't just give it the left pointer, give it the right pointer. Okay? So let's run that and see what happens. Oh, we get 100. Okay? We get 100 because 13 plus 7 plus 5 plus 9 plus 11 plus 18 plus 16 plus 21 is 100. And if you don't believe me, add it all up. Okay? Now let's just very quickly, before we finish, try to figure out exactly what's going on here. Before we do the return, I'm going to do a system.out.println t pointer dot data. Let's have a look at the data items that are being visited as this recursive call goes around. So it gets 13, then it goes to 7, 5, 13, 7, 5. So let's just have a look at that. Oh yeah, 13, then it went left, went to 7, then it went left, went to 5. It tried to go left, but it couldn't. So that recursive element finished, but here it then tried to go right, but it couldn't. So it went back to this node, this is the unwinding, and it tried to go right, and it could. So it went to 9, it tried to go left, it couldn't, so it went right, and it could. So we should get 13, 7, 5, 9, 11, 18, 16, 21. Okay? 13, 7, 5, 9, 11, 18, 16, 21. Let's see if that's what we got. 13, 7, 5, 9, 11, 18, 16, 21. Have a think about it. See if you can figure out what's going on in this recursive processing of a binary tree.